Right, production techniques and systems. This one should be fairly brief, as it's a lot more straightforward to explain. So, first in, CAD, computer aided design. Literally, all you need to know for this is that's what CAD stands for. Then we're talking about like advantages and disadvantages of it. So, CAD comes in two forms really. You get 3D CAD, which is like Fusion 360 or SolidWorks or whatever it is, or Shaper or Tinkercad or SketchUp, whatever. There's loads and loads of different software packages. Or you get 2D, which is like 2D Design, Affinity Designer, Adobe Illustrator, those ones, which are 2D. So those are great for drawing like graphics and things. If you want to draw something to be cut on the laser cutter, 2D CAD is great. If you want to 3D print something, you need 3D CAD to be able to do that. Some machines are sort of hybrid. If you want to use the CNC machine, CNC router, then that could be 2D or 3D CAD that you use. So the purpose of this lesson is to teach you about the advantages and disadvantages of all the things associated with it. So CAD, advantages are you can create incredibly detailed, complex, highly precise designs, which can be visually represented perfectly. Like you can get what we call photorealistic renderings off CAD systems, to the point you can show them to the client and the client would think it was a photograph of the real thing. So there's massive advantages to that. You know, you can show what would a building look like at nighttime and look like at daytime as the sun goes around the building during the day. What would happen to the shadows it casts? How spacious would a product look like inside if you were inside a car? Like how spacious is it going to be? Can you reach all the controls? There is so many things that CAD can do, way too many for me to be able to explain in this short screencast, because the technology is always evolving day to day. There's new capabilities being added to CAD. So the main point you've just got to understand is CAD means you can virtually model things. And with that, you can get renderings, you can get manufacturing data, and you can get incredibly precise, very editable designs. That means you could go back in time and tweak a little dimension, and then the whole design will update accordingly. And that's really good CAD modeling. The downsides are that it can be very hard to learn, and it's a very long learning curve to get to the point where you feel like a sort of grandmaster at it, as it were. And it can take years to get to that point, even though the software is getting easier to use and AI will gradually is gradually taking over more and more of it. But it requires a lot of grit and determination to sort of really think, right, I'm going to learn CAD properly now. So moving on, computer aided manufacture, so CAM. So this is looking at how do you then take your CAD model and actually get it into being a product. This is the limitations CAD always has, especially in schools. Like students will make lovely CAM models and you think, wow, what an amazing design. But then they can't make it. And so the actual outcome is handmade and it looks like, really rough and horrible. So we need CAM to be able to actually make that beautiful CAM model into a beautiful real product. So CAM, the good thing is here is that it's only getting cheaper and cheaper and cheaper to use. So CAM is like machines such as the laser cutter, such as the 3D printers that we've got. And you can see here there's like videos of 3D printing technology. There are the CNC routers, and this video has got incredibly satisfying slow motion of the CNC machines, like cutting metal, and you can see it slicing off very thin layers. And these things work by plotting sort of X and Y and Z coordinates, depending, your CAD model, the data generated from that will literally just be a series of coordinates, literally like a map, and it will just tell the cutter head where to go and how fast to cut it. The one on the top right here is a water jet cutter, which we've recently gotten in DC here, which is great because this can cut any material and it doesn't have all the overheating problems you get with laser cutters. And it can literally cut anything from like stone, glass, stainless steel, wood, plastic, whatever you want. You can put it in, it will cut it. So that's what CAM is. Now, CAM systems, you can't just chuck a 3D CAM model at it. You have to do what's called post-processing. So that involves taking your CAM model, you export it as what we call a 3D mesh. And then most CAM systems have their own software, their own CAM software. So you import your CAD file into, say, the 3D printer's own native software, and then it will slice it up into layers virtually, and that's its way of computing how to print it, for example. So all CAM processes have their own post-processing software as well. Now, Moving on to actual commercial manufacture, we have what's called flexible manufacturing systems. Old school manufacturing is you have a production line, like the Ford Model T factory line we've seen already, and that production line can only make one product, and that's it. If you wanted to change that product, you'd have to radically redesign pretty much the whole system. You'd need whole new machines. You need to train up people to do something new. That's an inflexible production system, and that's kind of what traditional conventional manufacturing looks like. Now, flexible means you've got machines which can do sort of all sorts of different things, and that's where robotics come in. So you get these multifunctional sort of fourth or fifth generation robots which can actually do all sorts of different functions. Like maybe they can weld, they can also check dimensions, they can also paint. Like they could be all sorts of things they could do. CNC machines are great examples of flexible manufacturing systems because they can pretty much cut most materials, and you can feed in your CAD data and it can cut most things as well. That's why they're so good. They're so flexible at what they do. And so that's really what it is. It's a company's ability to be able to tweak and change the design all the time, or change what they're manufacturing without having to completely overhaul the production system. Now, just-in-time, the video here will explain this better than I can, but just-in-time production is a system which involves removing the need to store spare of anything. So it might be if I'm the factory, my supplies would arrive just when I need them for me to be able to make a load of that product, and then I can send it out to the consumer. That's what we call really efficient or lean manufacturing, which we're going to get onto in a minute. So just-in-time production is like what most companies strive for. It means that you don't need a warehouse, you don't need storerooms to keep stock, because some stock will degrade if it's stored for too long. They aim to have a system where the materials arrive just as they're needed, and then they are used, and then they're sent out, and there's no waste, there's no spare kicking around. And they're not wasting money by buying stock that they don't need, for example. So that's what JIT is. Now, have a watch that Toyota video, because those guys, they didn't invent JIT, but they were one of the biggest pioneers of it. Lean manufacturing is sort of the next step beyond that. Lean manufacturing, if we talk about things being lean, like you might talk about like a lean economy or food being lean, it kind of it implies like sort of removing the excess from something. Removing anything unnecessary, or trimming the fats, like from whatever it is, and so in manufacturing, lean manufacturing means basically comes down to removal of waste, removal of unnecessary waste, and this comes down to continuous improvement. Like I mentioned before, like Toyota have been great at that, like continuously improving their production process to be more efficient, to be leaner, to be less wasteful. So if you're a lean manufacturer, you can be lean by reducing the quantity of material that is used to make a product. Now, that could start right at the beginning of the design stage. The designers could redesign the product so it uses less material, or it uses a narrower range of materials. Like instead of using like 10 different materials, they could redesign it so it only uses 5 different materials instead. And so then that makes it leaner. They could, like I say, reduce the quantity of material that's used. They could also design it so that it can be manufactured with more efficient technology. So it could be, instead of using massive injection molding machines that are very costly to run, perhaps they could use 3D printing instead. Or they can use a cleaner energy source for it. So they could make sure they run their factory on solar power, for example, instead. So that's kind of, or it will use less water, or there'll be very little wastage coming out of it. That's kind of what we're talking about with lean manufacturers. It has very limited negative impact on the environment and on the economy, and in all sorts of ways. Planned obsolescence, I've talked about this already, but this is where companies, they plan for things to go out of date after a time. And sometimes that's planned, sometimes it's accidental, but they'll design, especially electronics, they'll design and make things that they know will go out of date, because they will design something newer and better. If they're continuously improving, they will design something that is newer and better. So it's always important to think about how planned obsolescence comes to be, and why it's necessary and why it's also unnecessary, and how it's actually also a source of massive problems in design. So then moving on, this is another area where we're talking more about sort of the ethics of design, but we're looking here like thinking of planned obsolescence and taking that a step further. Now, really well designed stuff is designed to be repaired. Really, really well designed stuff is designed to be repaired by the user. Now, back in the day, when my dad was my age, cars were things that could be often mostly repaired by yourself. You could even, a lot of, I think it's very common back then, people would like change the oil on the car themselves. They would perform like procedures which now you think like, oh no, just go to the garage and get someone else to do that because like they don't know how to do it. So whereas back in the day, people would just buy a manual. You got these like things called Haynes manuals, and they would literally find the one for your car, and it showed you pretty much everything that you could do to your car in terms of self-maintenance. Whereas now, like cars are actually designed now so that you can't do it yourself because, of course, they make more money that way. Companies like Ford and GM, they actually make more money from the sale of after parts and servicing than they do from the actual car. So that's quite a thought when you think about it. Like that's why they can sell the cars like a bit cheaper, is because they know that they'll make more money from servicing and aftermarket care. Which is a bit criminal in my opinion. But yeah, so designed for maintenance. Now, things on, say, a car. The car's a good example because they're so complex and they're so abundantly used. But for example, hopefully you're not the kind of person who would, if you got a flat tire, would just scrap the whole car and go and buy a new one. You would, of course, change the tire or get the tire changed by someone else. If the windscreen wiper fluid ran out, you wouldn't just like throw the whole car away. You'd fill it up. If the petrol ran out, you get more petrol, or in this case, at Tesla, you'd recharge the batteries. Hopefully with Teslas, I mean, Tesla pledged like a 10-year warranty on their batteries. But hopefully with Tesla, like we're not really quite coming to we're only just coming to the point now where there's Teslas that are older than 10 years in terms of the consumer Teslas. So like the Model, the Model 3's got a bit longer to go yet, but it'll be interesting to see what happens when the battery packs actually start needing replacing. So those are things like, and cars, particularly older cars like ICE cars, internal combustion engine cars, sometimes they're actually designed so that things will go wrong at set mileages. Once the car reaches a certain mileage, something is programmed to go wrong. So then you will have to go to, say, the Ford dealership to get it repaired, and they will only be the ones that actually have that part to change it. And again, that's how they make money. But on a smaller scale, we can do a lot of things as designers to enable customers to be able to just repair stuff themselves and create a culture of repairing instead of just buying new or like just wanting to have this sort of disposable culture. We're trying to move away from that. So then moving more into the ethics of design, like it's really important that we've talked about fair trade already, but it's really important we think about the ethics of how things are manufactured particularly, and the working conditions. I mean, Apple were had up years ago over the working conditions of the employees at a factory that they use called Foxconn. Now, I think their argument was that Foxconn is not owned by Apple. It's like Apple have like sort of monopoly rights over the factory, but they say that they don't own it, so it's not really up to them like how the employees are treated and the wages they get paid and stuff. Which is, in my opinion, is like really dodging the blow there. But yeah, like ideally a good company is one that will look after its workers and it will pay them a fair wage. And if you're using overseas manufacturing, you're making sure that the workers in the factories that you're using are paid a fair wage. And it might be that if you're, I mean, this is particularly prevalent in the textiles industry, but it might be if you're a really responsible manufacturer, you'd hope that ideally you'd use, number one, you'd use materials that are sustainably sourced, and are not polluting, and also you'd use factories which don't employ slave labor or child labor or anything like that. You'd even better go to the factory and you go and scope it out and visit it, and you'd see like, what are the conditions like, talk to the owners, talk to the workers, like find out what's it like working there, and then if you're really sort of conscious of this, you get a better understanding of what, whether it's a good call or not to actually use, say, that factory, for example. Ethical decisions can go into material choice as well, and the way materials are sourced. I mean, diamonds diamonds are horrendous. They're known, often they're known as blood diamonds because they've been found in conflict zones, and so much conflict has come about from things like oil, gold, diamonds, anything valuable. Has been the cause of so many wars in the world, because countries trying to get a monopoly on a natural resource. So yeah, things like making sure that we don't buy materials from conflict countries, for example, or from certain regimes which you don't agree with, is important. Then another really big one is end of life disposal. I'm really annoyed right now because LG, yes, I am putting this out here, LG, in a very, 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 very small chance that you'll even bother watching this video. But yeah, I was really annoyed about this. Like LG, my washing machine, the little latch on the door had broken, and the result of that was that when you can't start the machine, and this is universal for all machines now, you can't start the machine unless the door is actually registered as being closed by the computer on the washing machine. And because the latch had slightly broken, the door wasn't shutting properly, and therefore the machine would not actually start or turn on, for a very obvious safety reason. But the thing that really annoyed me was when we contacted LG, they said, "Oh, this model of washing machine is 3 years old now. It's not supported anymore. So I'm afraid the part doesn't exist. So yeah, sorry, the only option you have is to buy a new washing machine." So that immediately made me think, hang on a minute, this is a perfectly good working washing machine. It is a tiny component that is broken, and you're telling me that is unrepairable. So yeah, stuff like that is really bad, and they design it so that it's not really fixable by you either. Yeah, so I find that kind of design is really unimpressive, and it's so obvious what they're doing there is just making sure that you end up having to buy a new one. So then the other thing as well, which is terrible, is obviously massive wastage of materials from what is essentially a perfectly good machine, which just has a tiny component that's gone. So that's where good companies will have what's called take-back legislation. So they will take back the old one as you buy a new one. So some washing machine companies, don't know if LG falls into this category. I think depending on the country as well, like say if you're in Germany, if you buy a Siemens washing machine, I'm pretty sure that the government will state that the company must take the one that you're getting rid of as they give you the new one, because then it's not, they literally, it'll be illegal to just throw a whole washing machine into like a massive garbage, a tip or a skip or something like that. So you will have to, like, that will have to be have all the parts reclaimed, that can be reclaimed, all the materials reclaimed, which is great. Like, and it's the same with a car. Like, you can't just throw a car away. Like you have to either pay to get it scrapped, where it'll go to a scrap heap and it'll actually have ideally all the parts removed and materials reclaimed and things, or you exchange and you trade it or something like that. But either way, like that's kind of what we're talking about with end of life